The eagle has landed. Welcome to Maths. This is Mangeya, the Maths eagle. Right. So this part is on bearings, and this video is made up of two parts. The first part is based on the explanations involving facts, concept on bearings. Then the second part, there will be questions that I will work out in this same video. Right. Then after watching this video, please like, share, and subscribe to this nice, powerful item. Let's start flying. Well, there are things that you have to understand first. Like we have angles on parallel lines. Those ones, they are key. You have to understand them so that you can be able to tackle and solve problems involving our bearings. Like, let me explain some of the key items that we'll be using in this case. These are parallel lines. Put my parallel lines. Right, these are my parallel lines, this line and this line. If I can put a line here, then this angle and this angle, I can say y and x. X and y, they are said to be the same. X is cos y. The reason being, they are called z angles or alternate angles. Alternating angles, they are actually the same, or z angles, they are the same. They are like on a letter z. One is inside, the other one is outside. It's on the outer side. Right, then we have this angle. If I can call it P, then P and Y, P plus Y add up to 180 degrees. Why? They are actually adjacent angles on a straight line. They are said to be supplementary. The same as P and X. P plus X is 180 degrees. They are also supplementary. They are called co-interior angles. Co-interior angles add up to 180 degrees. So supplementary means they add up to 180 degrees. So these are the key combinations of angles that you have to understand, especially when it comes to bearings. Then after this one, after understanding this, you have to know angles in a triangle that they add up to 180 degrees. Because sometimes you'll also be working with triangles. And the other thing, you have to understand the sine rule and the cosine rule. Sine rule and the cosine rule. Because after like illustrating or drawing triangles, bearings are statements. Use them to formulate triangles if there are no shapes that are drawn. Then after that, to work out whatever you have to work out, whether it's the side or the angle, you have to use sine rule, cosine rule. If the triangle is a right angle triangle, if it's a right angle triangle, then you can use Pythagoras theorem or SOHCAHTOA. Right, now getting into the facts on bearings. The first fact number one, some they call it facts. Wow, it's nice. Right, so the facts on bearings, fact number one, bearing, or you can say, north of all places, face same direction. Face same direction. North of all places, face same direction. Like if I can have chosen places here, I can say Zimbabwe, it's here. Then here I can have China. Then this side, maybe I can have something India. So if I can draw my north of Zimbabwe is this one. North of China is this one. North of India is this one. So if we are illustrating, we can say that all these the lines will be facing upwards. So they always face the same direction. So from Zimbabwe, China to India, something like this. So north always face same direction of all places. Then number two, north is a straight line. North is a straight line. So from this, you can be able to apply a concept based on angles on straight lines. Like you can have z angles, you can have adjacent angles, but mainly adjacent if it's like this. If this one is a straight line, then I can have north and north. There are two of them. Then if I can join them, then this angle and this angle, they are actually the same. X is x. Then this angle and this angle, y, x and y, we can say x plus y is equals 180 degrees. Why? Because they are actually adjacent angles on a straight line. This angle is adjacent to this. So they are supplementary, which means they add up to 180 degrees. Then from this same, I can also write another law or fact. I can call this one north is parallel to north. North is parallel to north, which means north line is always parallel to another north line. In this case, if they are parallel to north and north, they are parallel to each other, which means you can be able to apply, you put it here, you can apply these z angles, alternate angles, adjacent angles, even interior angles. Like if this angle is x, this one is y. I can say x plus y is 180 degrees. Why? Because they are said to be co-interior angles. They are supplementary. They add up to 180 degrees. Right, then the other thing that you have to understand on bearings is bearing actually is always from the north of the front point in a clockwise direction. So in fact number 4, bearing is always from the north of the front point in a clockwise direction. In a clockwise direction. So it's clockwise direction. My clock is like this. So its direction is this direction, this direction. So that's the clockwise direction. So you always have to take your bearing from the north of the front point in a clockwise direction. However, there are some abnormal cases that I will explain in this same video that it will not be from the north of the front point actually. Right. Then from this, let me give some examples. E.g., if I can say, let's say the bearing of A from B, let me change my ink. Right, let's say I can say the bearing of A from B is 60 degrees. Take note, it's called the 3-figure bearing. I have to put a 0 before 6 so that they were supposed to be 3 digits always. So in this case, you can check. Is the bearing of A from B? What is my front point? Is B. Which means, this one means the angle interpretation, the angle from the north of the front point, which is B, to the line with A, is actually 60 degrees. So A and B, take note, these are places on level ground, more like the one that I've used, Zimbabwe, China. So this one is Zimbabwe and B can be China, right? So from the north of B, that's the north of the front point in a clockwise direction. Please take note of that part. So this angle actually will be 60 degrees. If I can illustrate now, this one is my front point. Let's say this point is B. Then I have to draw my north at the front point, which is B. From the north of the front point, the angle is 60 degrees, like this. And A is somewhere on this line. And this line, like from B to A, please take note. BA is not supposed to be a bit much more longer or smaller. It's supposed to be the side that is appropriate to make the side of or to be the side of a triangle. But these ones, the bearing will help you to formulate shapes and usually triangles. So you can formulate or come up with a triangle. So this length AB, it must be appropriate enough to have or formulate a triangle. Take note of that part. Then from this, why did I put my 60 here? It's more like this. If I can have, this one is my 4 cardinal compass point, north, east, southwest. Between north and east is 90 degrees. Between east and south is 90. South and west is 90. Between north and west is also 90 degrees, right? Take note of that part. Then this range, this one I can say my first quadrant, this one the second, this one the third, this one the fourth. Right, so this first quadrant, these are angles from 0 to 90. And this one, these are angles from 90, was now above 90, to 180. Was up to this point is 180. Up to this point is 90. Up to this point 270. And this range now is angles from 180 to 270. And this one is from 270 to 360 degrees. So something like this. So if it's an angle that is less than 90, So it's supposed to be drawn somewhere here. Any line in this region. But if it's an angle that is more than 90 but less than 180, let's say 120, it's supposed to be in this region. Then if it's an angle more than 180 but less than 270, it means this region. Any line. Then if it's more than 270, so it's supposed to be this region. Please take note of that part. Now, if I can say maybe another example, let me give another example. If I can say, example number 2, A is 5 kilometers on a bearing of 120 degrees from C. From point is C, I have to draw my north at the from point, which is C in this case. So there's C here, and the angle is supposed to be 120 from the north of C. This one is 90 up to 120, and still need some 30 degrees, so I have to add something somewhere. So this is the line where I can have my A, and the distance is 5 kilometers from the north of the from point, which is C in this case, right? Then let me add some more examples. Example number 3, let me say D is 6 kilometers on a bearing of let me say 220 degrees from C. 220 from C. I must have my from point first. This one is my from point. I have to draw my north at the from point, which is C in this case. Then from the north of the from point is 220. It's in this range. So it's 220 somewhere. So this angle is 220 degrees from the north of the from point C. And my point is D is somewhere here. And the distance is supposed to be 6 kilometers from the north of from the point C. Right, let me add one more item. Number 4, I can say the bearing of C from A is 320 degrees, right? Please take note. From point here is A. Supposed to be from the north of the from point, which is A in this case. So my A, I have to draw my north here. Then I have to put A somewhere here. This one's my north. Then the angle is 320. 90, 180, 270, which means my 320 somewhere here. So this angle is 320 degrees. Then my C is somewhere on this line. Right, so that's how you work out things or angles based on bearings. It's always from the north of the from point in a clockwise direction. Right, then let me move on to what I can call abnormal cases now. Abnormal. These are more like special scenarios where sometimes they are not supposed to be coming from the north of the from point, right? Right, so the first part, I can say northeast. This one is from the north, however. Northeast. This one means 60 degrees northeast. So the angle is 60 degrees from north going to the east. To the east side. So it's from north going to the east. The angle is 60. It's actually 60 degrees. So if I can check, it's more like this. This one is my east, north. Then this one is my east. From north going to the east, this angle is actually 60 degrees. That's what it means. That's case number 1. Then case number 2. Case number 2, I can say, let me use the same 60 degrees. Let me use, in this case, it's southeast. 60 degrees southeast. Right. This one means 60 degrees. So the angle is 60 degrees from south going to the east. To the east side. The angle is supposed to be 60 degrees. So it's more like here. This one is my north. My east is this one, my south. So from south going to the east is 60 degrees. Please take note. That's why I have to call these ones abnormal or special cases. Because in this case, we are saying always that the key concept or the general rule on bearings is it's always from the north of the from point in a clockwise direction. But for this one, it's not from the north, it's from the south. I'm sure you can see that one. Then another case, I can say number 4, 60 degrees northwest. Northwest means from north going to the west. The angle is 60 degrees. Where is my north? It's north. This one is my west. So this angle is like this. If you can check, it's actually anti-clockwise, right? That's why it's a bit abnormal. Then next, let's say number 5. If I can say 60 degrees south going to the west. From south going to the west, the angle is actually 60 degrees. This one is my south, this one is my west. From south going to the west, this angle is 60 degrees. That's what it means, 60 degrees southwest, 60 degrees northwest, 60 degrees northeast, 60 degrees northeast, then north southeast. So that's the meaning of these items. Then we have more items. This was supposed to be 5, but I'll just call it 6. Then for this one, it's called due east. Due east. What does due east mean? Due east means 90 degrees from east. From the east line. That's what due east means. If I can say A is due east of B. A is due east of B. It means A is actually on the east side of B. From point is B. Then A is due east 90 degrees from the north of B. That's why you can have my A like this. Then number 7, if I can say due south. Due south means 180 degrees from north. That's what due south means. If I can say A is due south of B. Due south of B, so it will be, A will be somewhere here. This one, my from point is B, then A is due south, which means 180 degrees. So A will be somewhere on this line. Then the other thing, if I can say due north. What about due north? Due north. This is the same as on the north side of. When they say A is on the north side of B, due north means actually 0 degrees. So it's supposed to be on the north side, on that same north line. They say A is due north of B. This one means A is on the north side of B. It's still the same. It's still the same. If A is on the north side of B, then if I can have my from point is B here, A is on the north. This one is my north of B, which means A is somewhere here. If maybe the distance was 5 kilometers from on the north, then this distance is 5 kilometers on the north side of B. That's where you can find my A. So these are special cases or scenarios in bearings, right? I'm sure you've understood these things. Now let's get into the questions. The questions. Question number 1. Like these questions, I just got them from somewhere. Then you can use them to simplify concept or explain concept, illustrate facts that we've explained on bearings. Question number 1, it says, from a point on the edge of the sea. Please take note. You have to take note of the from point. Always from point. Sometimes the diagram they will be given. But in this case, we have to draw the diagram first. Then after that, we can now find whatever is supposed to be found in this question. Then they said, from a point on the edge of the sea, one ship is 5 kilometers away on a bearing of 50 degrees southeast. It means from south going to the east. Then the angle is 50 degrees. Then, and another is 2 kilometers away on a bearing of 60 degrees southwest. From south going to the west, the angle is 60 degrees. Find the distance between the ships. Right, so if I can, first thing is the from point. This one is my from point, is the edge of the sea. Then this from point, let me draw my item. Right, from the edge, from a point on the edge of the sea, one ship is 5 kilometers away on a bearing of south to east. South to east is this one, going to the east. So another ship is on this line. The first one is on this line. and the bearing is 50 degrees, which the angle is 50 degrees, distance is 5 kilometers. So the ship, I can put it somewhere here. That's where it is. Then, and another is 2 kilometers away, only a bearing of 60 degrees southwest, from south going to the west. The angle is 60 degrees, and this distance is 2 kilometers. So it's somewhere here. Then they said, how far? Find the distance between the ships. Distance between the ships, it means the distance is this line. I can call it x. I'm sure if you can see, we now have our nice triangle. Our nice triangle. And this triangle is like this. The east is like this. This is our triangle. With this angle 60 plus 50, that's 110 degrees and 5 kilometers, 2 kilometers. Then you have this side x. Now to solve for x, then we must use the cosine rule or the sine rule. Now for which one to use, the sine or the cosine rule in this case? Cosine rule says what? A squared is equal to b squared plus c squared minus 2bc cos a, where b and c are the sides which makes up the angle. Like in this case, if I can have this angle, that's my theta, then b and c must be these ones. Then for you to be able to see whether you can use cosine, you have to check. Do you have your b and your c? The angle, you have it. That is 110 degrees. Then your b and your c, we have them 2 kilometers and 5 kilometers. So in this case, we can use the cosine rule. So we can substitute. A is the side opposite 110, the given angle, that is x. So I can substitute now x squared is equals to, then b and c, 2 and 5. 2 squared plus 5 squared, then minus 2 times 5, then cos of the angle, that is 110 degrees. That is given in this case, right? Then I can say x squared is equals to 2 squared plus 5 squared. 2 squared is 4 plus 25 minus 2 times 2. This will be 20 cos 110. Then x squared is 29 minus 20 cos 110. Then to remove the square, I can just put square roots both sides. It will be square root this side and square root this side. Then I'll get my x is, you can make use of a calculator, square root of 29 minus 20 cos 110 is 6.9986. Right, something like this. Then to 3 significant figures, supposed to be 7.00 to 3 significant figures. So this will be my distance in kilometers. Done. Question number 2. Seat A is 300 kilometers due east of seat B. Then seat C is 200 kilometers on a bearing of 123 degrees from seat B. How far is it from C to A? Now on bearings, the other key things, angles, they are the one that matters the most. So you have to work with angles first before you can put those distances, 300 kilometers, 200 kilometers. So illustrate your angles first. So they said we have seat A, that is 300 kilometers due east of seat B. So from point here is seat B. Based on this part, let me put it here. I have to draw my north at the from point. And this one is due east of seat B, which means my B is somewhere here. And it's 90, due east means 90 degrees from the north. Please take note of that part. So I put my right angle like this. So if my seat A is somewhere here, and the distance is 300 kilometers. So it's statement by statement, angle by angle. Right, the second part, seat C is 200 kilometers on a bearing of 123 degrees from B. It's still from seat B. So the angle from the north, this is my angle, is 123 degrees. So it's something like this. And this angle is 123 degrees. So it means my seat C is somewhere here. Then the distance is 200 kilometers. Like this. Then how far is it from C to A? This is the distance. I can call it X. This is the distance that we're looking for, right? So what do you have to do? You have to look for this angle. This angle between the sides, that is 300 and 200 kilometers. And this angle actually, you can see this one is 90. And up to this line where they say it's 123. So to find this angle, it's just 123 minus 90. That's the angle. So it's 123 minus 90, 33. Yeah, it's 33 degrees. So this angle is 33 degrees. Then I have my B and my C. I can use the cosine rule, right? So please take note, this B and C, they are not like based on this triangle A, B, and C. No. These are for the ones in our formula. Formula is A squared is equal to B squared plus C squared minus 2BC cos A. I'm sure there are some that I used to label the side, say the side opposite side angle A is A. Yes, that will work. But this one is the inverse of formula that you have to use. So whether there's P, Q, R, X, Y, Z, or whether there are no letters, then this formula still works. But what you just have to know is B and C are the sides which makes up the angle. And this A is the side that is opposite the given angle. In this case, is 33 degrees. So my A is X. I can substitute now X squared is equal to B squared, that is 200 squared, plus C squared, 300 squared, minus 200, then times 300, then cos angle, that is 33 degrees. This is my triangle, right? Triangle ABC. X squared is equals to, then from this one, I'll just say, okay, instead of writing everything, let me just say X is equals, both you put square root both sides. So it will be square root of 200 squared plus 300 squared minus 200, 300, then cos 33. Let me just punch everything. It's 200 squared plus 300 squared minus 2 times 200 times 300, then cos 33. You get your answer? That's 131,593.2097. Then square root of this answer now, you get 362 degrees. 0.7577. Then to three significant figures, 0.3 kilometers. So this one will be the distance between C and A. Right, next, a man prospecting for oil in the desert leaves his base camp and drives 42 kilometers on a bearing of 32 degrees. He then drives 28 kilometers on a bearing of 154 degrees. How far is he then from his base camp? And what is his bearing from it? Right. So these things, please imagine like you're actually the person who is actually walking. You're walking from one point to another point. Right. So your starting point is this one. Let's put your starting point is this one. That's your starting point. Draw your north at the starting point. So this one is your starting point. I draw my north. Then from this starting point, this man drives 42 kilometers on a bearing of 32 degrees. So from the north, the angle is 32 degrees. Like this. Then, so this man was walking on this line. The first he walked about for 42 kilometers. For 42 kilometers, right? And so a man prospecting for oil in the old desert leaves his base camp and drives 40 kilometers on a bearing of 32 degrees. That's the first part. Then the second part, he then drives 28 kilometers on a bearing of 154 degrees. So at this point now, he changed his direction. You have to draw another north at this point. And from this point, he then changed to 154 degrees, which means from the north, the angle is 154 degrees. It's somewhere like this. So this angle is 154 degrees, exactly like this. So the man is somewhere here. And the distance is 28 kilometers. Where is the man? It's here now. This is where he is now. Then they said, how far is he then from his base camp? I have to join the two items. So from his base camp, I have to join this point and this point. This man is here now. This is the distance x. Right. Then what I have to do now is to find the angle. You can say there's 2 kilometers, 28 kilometers. These form the sides of a triangle. I can see there's a nice triangle that is there. Right. So this is the angle that I must have. This angle here. This is the angle that I need between 42 and 28. But this angle is made up of two parts. You have this part. This part I can now say this north is parallel to this north. So north is parallel to north, so I can apply Z angles or alternate angles. This is supposed to be 32 degrees, right? Then this angle on this side, is a relationship with 154. North is a straight line, so this angle is supposed to be 180 minus 154. Why? Because they are adjacent angles. So you can say 180 minus 154, 26. So this angle is 26. And this one angle is 26 plus 32, you get 58. So this whole angle that I need is 58 degrees. Now I have my nice triangle. It's like this. This is my nice triangle. With my angle here, 58. Then this one is 42 kilometers. This is 28 kilometers. This is the triangle that I have now. So this one is 42 and 28 kilometers. I have to find this side, which is x. I can use cosine. So applying cosine rule, I can say here, a squared is equal to b squared plus c squared minus 2bc, then cos a. All right. So please take note of this formula. If you can see, these are on this one, the signs are not labeled, right? But this formula still applies. Why? It's the universal formula that you have to apply. My a is a side opposite the given angle, that is x. X squared is equal to b squared. I can say 28 squared plus c squared. Then this is 42 squared minus 228 42, then cos 58. Then I can work out this one. X squared is equal to 28 squared plus 42, 28 squared plus 42 squared. Then 2, 5, 4, 8. Then next 2 times 28 times 42. 2, 3 cos 58. Now to find my x, I just put my square root. 2548 minus 2352 cos 58. Then I'll just put my square root. Square root of 2548 minus then cos 58, 47.6. So this one will give you 47.6. And these are kilometers. So the x is 47.6 kilometers. Now the second part, which is saying what is the bearing from it and what is the bearing from it. Right? Where is this guy? Where is this guy? Let me. Right, this guy is somewhere here at this point. I have to draw my north at the point because it's now from where this guy is. So you always have to draw the north at the on your from point, right? So this is the angle, this is the line that I have. Then the angle that I want is this angle. Let me change my ink color to blue. This is the angle that I want. So if I can find this angle, that's the bearing of this man from his base camp, right? From his original point. This is the original point here. So the angle is this one. So to find this angle, you have to check. It's made up of which parts? We have this part. This part actually, taking this north, and this north, we can say this angle is actually equal to 26 degrees. So you can fill in whatever can be found. Why? Because these are actually Z angles, right? Or alternate angles, they are said to be the same. So it's 26 degrees, right? Then you can say, but you might have this, you might need this angle, right? So this angle, if you can have this angle, you can say 360 minus 26 minus this angle. Then you can get your bearing. That is the angle on this side, right? So you have to find this angle. How can you find this angle now? Right? This angle, if you can use our shapes, then we can take our triangle, then find this angle, let me call it theta. We can be able to use sine rule or cosine rule. since we have this side is 47.6 kilometers, then we can use this side. We can say A over sine A is equal to B over sine A over sine A. It's equal to B over sine B. But in this case, we want to find the angle, so you have to put angles on top. So it's sine A over A, it's called sine B over B, like this. Then sine A, that's theta that we're trying to find. So you say sine theta over A, that is the side opposite this angle theta, is that one, 42, is equals to sine 58 over side opposite, that's 47.6. Then sine rule is a bit much more easier, you cross multiply. Or you can just take this 42, you put it on this side. Alright, let me cross multiply. 47.6 sine theta is equals to sine, actually let me say 42 sine 58. Then you divide by 47.6 by 47.6 both sides. It will be sine theta, this will cancel out, is equals to 42 sine 58 over 47.6, like this. Then to find our theta, I can say arc sine of 42 sine 58 over 47.6. Then I can just punch everything in my calculator. So my theta will be press second function and press sine. Then it's over. Then it's 42 sine 58. Just press exactly as it is there. Over 47.6. Make sure your calculator actually is in degrees mode, right? Otherwise, if it's in radians, like my calculator, then you see trouble. So it's 48.4 degrees. That's this angle. So it's 48.4 degrees. Now I can find my angle now. If I have this one, I can now find my angle. So this is the angle that I have to find. So to find this angle, I subtract this whole item from 360. Then I have my bearing. So I just say bearing now is 360 minus 48.4 minus 26. Then I'll have my bearing. So it will be this one plus 26. Then from 360. Then it's 285 point, which is 285.6 to one decimal place, angles in degrees, right? Take note of that part. So this is how you deal with questions like these ones. Right, next part is still more like the same as the one that we've read out. It's saying a boat sails 4 kilometers on a bearing of 38 degrees and then 5 kilometers on a bearing of 67 degrees. So this one I will illustrate the item, then you can just solve this one. So the first part is the from point. This one is my from point. Let me put my from point. This one. You have to draw your north at the from point, like this. Then a boat sails on a bearing of 38 degrees and then 5 kilometers 67 degrees. So you can put this one is 38 degrees. This is the boat. Then the distance is 4 kilometers. Then it's now here. I said and then. So it means after having sailed for this distance of 4 kilometers, it then changed the direction to 67 degrees. I have to draw my north. So you always have to draw your new north on this line, if there's a change in direction. Then 67 degrees now is this one. So just put it in such a way that it will be a bit much more wider than the 38 degrees. This will be 67 degrees from the north. And the distance is 5 kilometers. How far is the boat from its starting point? It means from this point to this point. It's now here. That's where the boat is. So how far I can put this one as my x. Now, you have to find the angle in between these labeled sides. How can you find the angle? It's made up of two parts. You have this part. This part, north is part to north. It's 38 degrees. These are alternate angles or z angles. Then this angle on this side is another part. This one, north is a straight line. So this north is a straight line. You can say 180 minus 67. Then you get that angle. 180 minus 67 degrees. Then you get 113. Then the angle that you need is 113 plus 38. 151. So the total angle, it will be 151. So we have a nice triangle like this one. And this triangle with 4 kilometers, 5 kilometers, and 151 degrees. And you find this side x. You can see? Now they say, the second part, they said calculate the bearing of the boat from its starting point. Now, to find x, please take note, to find x, you have to use the cosine rule, right? A squared is equal to b squared plus c squared minus 2bc cos a. Now, for the angle, that's part B, calculate the bearing of the boat from its starting point. You have to go where the boat is this point. You draw your north. Then even your east. Then after that, the angle needed is from the north to this line. This is the angle that we need, right? And this angle basically is made up of two parts. We can have this part. We can have this part. This part, actually, this one up to this red line is we can say north is parallel to north. So you can use co-interior angles with 67 degrees. 180 minus 63 minus 67, it will be 113. Or just say it's the same as this 113, because they are z angles, right? Then you can find this angle here. After finding this angle, I can call it theta. Then you say this theta plus 113, you subtract from 360 angles at a point. Then you can find your required angle. Just like that. To find theta, you can now use this triangle. Go this side, we have x. Then use the sine rule. Sine rule, then you find your theta is somewhere here. Sine theta over 41 over 4 kilometers over 4 is equals to sine 151 over x that we found. Then you can find your theta. You can use that one to find your required bearing. Question number 6. This one looks like the same, so I'll just draw the diagrams, then explain something. But question number 6 saying a ship leaves port and travels 21 kilometers on a bearing of 32 degrees and then 45 kilometers on a bearing of 287 degrees. Calculate its distance from the port. Then part B, calculate the bearing of the port from the ship. Please take note, from point is key. So here we have a ship. We leaves port and travels 20 kilometers on a bearing of 32 degrees. I must have my from point here. Let me say this one is my from point. I have to draw my north at my from point. Then it leaves and on a bearing of 32. So 32 is something like this. 32 degrees. So this angle 32, please, you don't have to use your protractor. No. It just approximately where is your angle. Sometimes even the graph is given, you are given the diagram, then they even write drawn not to scale, which means you are not supposed to even use your protractor, right? So 32 degrees, 21 kilometers, and then 45 kilometers on a bearing. And then it means, the moment they say and then, it means it's now at this point. You have to draw another north. And the bearing changed. Is 287. So 287 is more like this one. Up to this point is 280. It's 270. So it's somewhere here. Something like this. Wow. And this angle is supposed to be 287 degrees. This angle. Then they say it here. And how many kilometers is 45 kilometers? That's 287 degrees. Then they said in this case, let me change my ink. Then they said, calculate its distance from the port. So this one is my port. I have to join. This is the distance x that they are looking for, right? So the distance from the port. That's the distance that they are looking for. Please, don't make an error to end on your north. No. Just extend, or you can just end even before your north. Right? Otherwise, you take that one as more like it's on the north side. No. They didn't say and ends up on the north side of its starting point or port. So that's why I have to extend up to somewhere here. Right. Now to find your x, you have to check your triangle. Which triangle do we have? We can have this one is 32 degrees. North is parallel to north. So this angle is 32 degrees. Right. Then to find this angle, because you must have this angle. This is the angle that we must use to find. That will be the angle inside our triangle. To find that angle, it will be 287 minus 32. So 287 minus 32 degrees. Then what we get? 255. Actually, let me find this one in stages, right? Because this angle up to this point is 287, right? But up to this point, let me take from this point to this point. Then from this point, this one obviously, notice the straight line is 180 degrees. So I can say 180 plus 32. Then I subtract from 287. So it's 180 plus 32. That will work. Then 212 from 287. Then I get 75. So this angle is 75 degrees. There are two ways. I can first subtract 287 minus 180. Then 107. So 107 will be this angle. This angle is 187. Then I will subtract 107. Then I will subtract 32. I will still get 75, right? Then not find your x. We have a triangle. It's a triangle like which one? It's like this one. And this one is my x. This one is my 45 kilometers. This one is my 21 kilometers. And I have my angle 75. Then I have to use the cosine rule. Done. Then the second part B, calculate the bearing of the port from the ship. Now this one is, from point is the port. This one is my port. From where? From the ship. So the ship is here. So I have to draw my north where the ship is. Then the angle from the north to the port. So this is the angle that you might need. This one I can call it alpha. That's the angle that we need. Right. So this angle, to find it, I'm sure you can be able to mix these items. Let me change my ink. Right. You have this angle. This angle you can find it from the triangle, right? You can find it right away from the triangle. After you found your x, then you can use the sine rule. You can find this angle here. Then after finding this angle, then we can have this angle here. Let me say, because you can use the concept that north is parallel to north. This angle here, let me mark this angle on this side. This angle, if I can use this north and this north, these two angles, actually, this one I can find my z angle, which is this side. And this side is actually 75 plus 32. 75 plus 32 is what? 75 plus 32. 75 plus 32 is 107. So this whole angle on this side is 107 degrees. Let me mark with a different ink. Use black. So this angle in black. This is the angle that I'm saying it's 107 degrees, right? Then plus this angle here, up to this line. Then we can have your bearing. Done. Are there more questions? Yes, we have this one. So this one I also explained the same. A girl walks 50 meters on a bearing of 25 degrees and then 200 meters due east. So this one the same as what we're doing. The from point first, I draw my north. And this girl walks 50 meters on a bearing of 25 degrees. This angle is 25 degrees. And then, after this girl is walked about 50 meters, she changed direction. Then you have to draw your other north. Then due east, it means 90 degrees. This 90 degrees. So she walked about 200 meters due east. And the girl is now here. Then what about our question? How far is she from her starting point? This is the distance. I can call it x. Then the angle that you have to find are the angles in between the two given sides. In this case, we have this angle, which is 25 degrees. Why? Because these are alternate angles. And this angle is actually 90 degrees. So my total angle that I have to use here is 90 plus 25, which is equals to 115 degrees. Then apply the cosine rule. You can now find your answer in this case. Right. Like, share, and subscribe to this nice, powerful item. The Eagle signing out. Thank you.